Okay, so it's a 9-point system. If that lamb, when we score it at 20 weeks of age, has no wool on it, we give it a 0. Okay, if it has roughly a quarter of its body covered with wool, it gets a score of 3, and so on. So low scores are good, and we've gone through all these rams, and if they have problems, we flag them.
How about the OPP scores and
What's this mean?
well, high or low is good.
Neither of them. That's not true there. These are different markers, if you will. Are you familiar with scrapie markers?
Yeah.
Okay. It's similar to that. If an RR is desirable for scrapie, a 1-1 is good for this. A QQ is equivalent to I don't have anything real bad there. Because the sire basically was a 1-1, so every progeny got a 1, so they got one good allele if you want to think of that one. Okay, so
Would
there's a
a
lot.
cube be equivalent to a 3?
Pardon me?
Would a cube be equivalent to a 3 then?
We don't really know yet how this works entirely. We don't know whether one is a. I don't know how this is going to come out in gene seq in terms of how they're going to present the information. In our case here, animals that had at least one risk allele, and that's either a 2 or a 3, were 3 times more likely to have OPP than an animal that did not have that risk allele.
We're looking for 1-1s.
We're looking for 1-1s here, okay? So there's a lot of data on there. It's not easy to sort this out. So how do you work with this? I don't know how to do it genetically right because we're measuring traits here that haven't really been recorded before. We don't know what the heritability for those traits are. We don't know what the genetic correlations between them. We can't develop a classical selection index where everything gets weighted nicely. So I'm just going to use a little farm-boy common sense here if you allow me to do that. So here's what I've done. I've basically gone in and said, okay, if an animal, like Greg, if an animal is really susceptible to scrapie, I'm not going to keep it no matter what. It's a red flag and it's gone. If an animal has horns or spurs, I'm not going to keep it. If it's basically colored, if it's solid black or like a Romanoff pattern, I'm going to get rid of it. And if it's got structural problems, I'm going to get rid of it. So if I said, here's minimum standards and you got to beat those, then these animals here with the red squares around them, I get rid of all those animals. So 1, 2, 3, 4, 5, 6, 7, maybe 9 out of those 17 animals we get rid of because I said we're just not going to tolerate it. So now we're left with a much smaller data set to work with. Okay? And I can take those animals and I sort them now with the things that are important. Type of rearing and ability to shed. So here's what happens. I start with this top pair of animals here, and they're both reared as triplets, and that's really good. This animal is genetically resistant to scrapie. This animal is susceptible to scrapie. They both have the same genetic merit for resistance to OPP. They're both white, but this animal is almost completely shed out, and this one's got all its wool. So of those 2 animals that are triplet reared, which one's the better animal? Top animal. Oops, I should have done this one. Okay, I basically went in and I put green squares around those things that are good. You compare those top 2. You compare those top 2 and this first one, they're actually full sieves. Okay, they're full sieves, but one of them's better than the other. Okay, full sieves don't have the same genes to get samples. Okay,
You know your mom and your dad were both QRs.
yep, that's exactly right. Okay, so now I'm going to look at these animals that were reared as twins. And you go over here and look at them, and this one has shed everything off, but the other 3 have most of their wool on. This animal is resistant to scrapie, and the others aren't completely resistant. So this top animal here, the 628, is better than the others that were reared as twins. And then I ask the question, okay, is this guy, the one that's reared as a twin, better or worse than the one that was reared as a triplet? And this can get kind of subjective, but this one was reared as a triplet, this one is a twin. This one's got an advantage in terms of resistance to scrapie. They're both white, and this one is shed out completely. And in that case, I'd probably go with the one that's reared as a twin. So out of those 17 sons that we started with, we end up with these two that I'm keeping back as potential replacements, and they're pretty good sheep. Okay? I haven't said anything about weight. I'm not trying to increase the weight in this population, really, but that's the way I go through this. So every fall, I get this data back on lots and lots of sheep and go through this exercise and identify those ram lambs that I want to keep back.
When you get the OPP markers figured out, how will that weight in comparison to your scrapings markers?
That's a real interesting question. Right now, the frequency of the best form of the gene for scrapie in this population is about 50%. And we're fairly similar over here also for OPP. So I suspect that those two things will continue to get weighted about equally in there. But what will happen over time real quickly is that we'll get this horn situation cleaned up fairly fast. And we won't be throwing as many out for that, and we'll do the same thing with the black. So those things will become less important over time, which allows us to have better intensity on those other things. That makes sense?
Don't you think the wool will also do that?
I do. I should have brought that summary in there, but I've been very surprised how quickly that's coming off.
I think that'll go
I
away.
shouldn't say, I didn't know how quickly it would. I would think it wouldn't be influenced by too many genes, and therefore it might be fairly easy to come off. But that flock's starting to look pretty clean out there now. Okay. This works, even though it's not sophisticated genetically, okay? It works if you get a lot of sons per sire. Because you can come up with 2 or 3 out of there that, you look at them in the records and they're pretty good. They're meeting your categories that you want. Okay, so here's what we're going to do. We're producing this population. Over time, what we're going to do is we're going to compare them to 2 industry standard breeds. And that'll form the basis of whether or not our new population outperforms what's already out there or not. And whether or not it should be released to the industry. So we're going to compare it to the polypate. Is a good wool breed with good prolificacy into it, and to the Katahdin, which is our most popular hair breed of sheep. Okay, so we are now establishing polypate and Katahdin flocks at our research center. They also lamb and may out on pasture, just like our easy care. So they're going to be our genetic controls to gauge how well our new line is going to do. And here's what the design of that experiment's going to look like. We're going to have a total of 400 ewes of each of these 3 breeds. We're going to breed half of those ewes to rams of their own breed. So Katahdin ewes we bred to Katahdin rams, polypay ewes to polypay rams, and our easy care sheep to easy care rams. So we're going to compare them for the productivity as purebreds, raising purebreds. And then we're also going to make half of the ewes to a terminal sire breed, to get at what a commercial producer would do in a commercial situation. I think there could be a big difference in these 2 things, and I think that the terminal sire breed that we use out here is really important. We could cause a train wreck out here by using the wrong terminal sire breed on pasture, and by that I mean a blackface breed. Okay, so I think what I'm going to use will be Texel Rams as a terminal sire breed.
And when we talked about that, when I was up there this summer, and we talked about why the terminal sires cause it's due to size. I mean frame size. That's what we were kind of talking about. Was that correct?
Well, I don't think so. I think these ewes are going to be giving birth to twins and triplets, a few quads. And the frame size, I mean, they're not going to have dystocia issues.
Right.
Okay.
Right. But
Okay, so I think what happens. Okay, here's my biases again. Okay, we've done lots of work evaluating sire breed effects on lamb survival. And here's my take on it: is that there's an antagonistic relationship between the mature size of a breed and lamb survival. The bigger the breed of the sheep is, the lower the lamb survival is.
And that's what I was talking about.
Okay?
Frame size.
Now, that being said, Producers get around it by working the tail off the lambing barn.